Day 12 notes 5.7 models of quadratic functions. We're going to do one problem together, and that's from page 214 in your book, number 10, the breathing problem. So your nose, windpipe, and so forth hold about a pint of air. So when you breathe in, the first pint of air to reach your lungs is air you have already breathed before. If you breathe more than 1 pint, the rest of the air reaching your lungs is fresh air. The maximum amount you can inhale on any one breath is about 4 pints. So what we're going to do is we're going to sketch a graph of F that represents the pints of fresh air reaching your lungs as a function of A, the total pints of air breathed in. And let's take a look and we'll explain why the function is linear and tell its slope and A intercept. So first, let's just kind of talk about what this graph is going to look like. All right, so we are comparing A, which is the number of pints breathed in, of air breathed in, versus F, which is the number of pints of fresh air reaching your lungs. And we're told that the maximum amount you can breathe in is about 4 pints. So I'm just going to kind of scale this axis here. Every 4, I will let be 1 pint. So there's 2 pints. There's 3. There's 4. And I'll do the same scale for the number of pints of fresh air reaching the lungs. So every 4 will be 1 pint. All right, so if we're going to go ahead and graph this, we have to think about what it's telling us, right? It says the first pint that reaches your lungs is air that you have already breathed before. So when you're breathing in, that first pint that reaches your lungs is not fresh air. It's air that you've already breathed before. Then after that, we're going up. Right? If I breathe another pint, then that means 1 pint gets into 1 pint of fresh air reaches my lungs. If I breathe another pint, so I'm at 3 pints, now 2 pints of those is fresh air reaching my lungs. And then finally, if I breathe in my maximum of 4 pints, the most amount of fresh air I can get in my lungs is 3. So you can see we've got these points here. We can tell that this function is linear because as we breathe in more pints, it is going up, or the amount of fresh air reaching our lungs is going up at a constant rate. So we can say the rate is constant. So what is that rate? Or another word we can talk about is our slope. So our slope, we should recognize, is going to be 1. And what's our A intercept? So when we don't have any fresh pints of air reaching our lungs, what's our A value? And we should see that our A intercept is also 1. Okay, go ahead and write the equation of this function f in terms of a. I'm going to give you a second to think about that on your own and then come back and check when you've got it. Okay, so hopefully you were able to figure out that the function f, which is the number of pints of fresh air, in terms of the number of pints that you breathed in, so f of a is equal to the number of pints you breathed in minus 1, because this 1 we have to subtract because that's air we've already breathed in. Now we're going to go ahead and talk about what percent of the air reaching your lungs is actually fresh air if you inhale 1 pint, 2 pints, 3 pints, or 4 pints. So what we're going to do is if we're inhaling 1 pint, we're going to let A equal 1. So if A equals 1, we're really finding f of 1. And when we plug that into our function in part B, we would get 0. So to figure out the percent, we take 0 over the number of pints that we're breathing in, and in this case, it's 1. So 0 over 1 goes to 0%. Okay? Let's go ahead and find out for 2 pints. So if we breathe in 2 pints of air, that's when A is equal to 2. We are finding f of 2, which is going to be 2 minus 1, which we just get 1. To figure out the percentage, we're going to take the amount of fresh air over the number of pints that we breathed in. And when we figure out the percent, we should get 50%. And then for 3 pints, we can do the same thing. This time, A equals 3. And so when we're plugging 3 into our function, we're going to get 2. So figuring out the percent this time, we take 2, that's the amount of fresh air getting to our lungs, over 3, the amount of air that we breathed in. And this is going to go to 66.67%. And then finally for 4 pints, we're going to do the same thing. A is going to equal 4 because that's how much we're breathing in. So we're going to plug in F of 4 and we will get 3. So to figure out the percent, the amount of fresh air over the amount that we breathed in, and we would get 75%. Now we're going to plot the graph of percent of fresh air reaching the lungs as a function of pints of air breathed in. So we're going to consider our ordered pairs are going to be our A, comma, our percent that we found in part C. So if we're creating ordered pairs, when we have 1 pint of fresh air, 1 pint breathed in, it's 0%. And then we can go ahead and say, well, when we breathed in 2 pints of air, we got 50%, okay, of fresh air reaching the lungs. And then when we had 3 pints, we are at 66.67%. And then finally, our last ordered pair is going to be 4.75%. So now over here, we are going to compare our amount of air breathed in, so it's A, compared to the percent of fresh air. Okay, so this is percent of fresh air. And I'm going to scale it very similarly. So every 4 is going to be 1 pint of air breathed in. And I'll do the same thing and kind of go up by 25% increments. 1, 2, 3, 4. So every 4 will be 25%. That's 50. And there's 75. So now when we go ahead and we plot these, we have the point 1, 0. We have the point 2, 50. We have the point 3, 66.67, so about here. And then at 4, we're at 75%. So if we connect these, we should get a graph that looks something like that. So hopefully we can see that this function is not a linear function. And why? Well, this time our rate of change is not constant this time. So rate of change is not constant. And that's why it's not linear. When it's linear, our rate of change is the same between every 2 points. Okay, so we can think of it like the slope. If we were to find the slope between these first 2, it's not going to be the same as it is between these 2 points or these 2 points, etc. Okay, if you have questions, let us know.